Okay, so we are now on chapter 6 in the lecture component, which is on the fundamentals of potentiometric titration, redox titration, and voltammetry. So this topic requires knowledge in electrochemistry, which I suppose you already have, no? Kasi ako ay medyo na-delay talaga kasi I want you to have more time sa assessments. Okay? But anyway, I think you have naman the knowledge na, pero dadaanan pa rin natin sila. Okay? So this is the chapter outline. We're going to discuss all of this today. So we're going to talk about electrochemistry and electrochemical cells, what is the Nernst equation, and how to solve for equilibrium constants in electrochemistry, redox titration, paano yung titration in electrochemistry, no? And then some examples of potentiometric and voltammetry, no? Okay, so let's start. Let's begin with defining electrochemistry. We define electrochemistry as the field of chemistry which focuses on the conversion or the interconversion of electric energy to chemical energy and vice versa. Okay? So, ibig sabihin, ito yung field ng chem na focus sa exchange ng matter to electricity. Okay? So, yung matter being the chemicals, no? And then yung electricity is yung kuryente mismo. Okay? So, this is very, uh, this is very used in our daily lives. For example, itong aking device, itong aking iPad, itong aking pencil, itong mouse, itong laptop, lahat, no? Halos sa paligid natin, they are all powered by this topic, electrochemistry. Okay? So lahat ng ating mga portable devices, cellphone, laptop, um, basta may battery yan, may electrochemistry doon. Okay? And not only them, no? If you go to your kitchen, you may find copper coated kitchenwares, no? If ganun kayo ka tito or tita, no? Familiar na kayo sa copper coated kitchenwares, no? Even them are products of electrochemistry. Okay? So it seems that this topic is quite off tangent sa field nyo. Kasi your field is more on medical field, no? So aligned kayo with medicine eh. How come na i-discuss natin yung usapang battery, no? Kasi ganito, electrochemistry can also be applied in your field. How? I have two examples here, and these are just few of the many applications of electrochemistry. Okay, so let's talk about this device here. You should be familiar with this. If not, okay lang. So this device is called the glucometer or the glucose meter. I actually have one here sa bahay, although walang diabetic sa amin. Just so happened na natripan ko lang bumili dati sa Bambang. Okay. So this is the glucose meter, and then you have a test strip here. Okay. Then in order for you to measure your glucose level, you need to prick your fingers, no? Ipiprick mo siya using a lancet, yung pinipindot tas biglang tutusok. Kaya tusukin mo na lang yan manually, okay lang. So you prick your finger and then you allow the blood to basta lumabas yung blood. So allow mo lang yung blood lumabas dyan, and then you will collect the blood in this very small well. Okay, so if you check the test strip kasi, there is a small well, square well yan. So dun mo ilalagay yung blood mo. So kunwari ito yung blood mo, kulay pula. Yan. Ididikit mo yan until yung blood pumasok doon sa well. And then you allow this device to do its measurement for, let's say, around 5 seconds. Then after 5 seconds, lalabas na. This is your sugar level. Okay. Commonly, the sugar levels are reported in millimoles per deciliter. Okay. In this case, this is millimole per liter. Okay, so just multiply this by 10, you will get the deciliter, the deciliter version. Okay, so actually mababa tong glucose level niya na to, no? So yan. But anyway, so ganun. Asan yung electrochemistry dito, you may ask, no? The electrochemistry here is the entire device itself, including the test strip. Okay? So what happens here is that ito may battery to. So ibig sabihin may kuryente yan. What will happen is that yung inyong glucose, I mean yung blood nyo, remember yung blood nyo may mga components yan that can that can uh, allow electricity to travel. Okay? So pwede niya hayaan yung electricity mag-pass through sa kanya. So gagawin ng device is i-measure niya yung voltage difference, no? Kunwari, naglabas siya dito ng 10 volts, tas pagdating dito, 9 volts na lang. So, depending on the voltage difference or in the current difference, no? Depending sa difference ng reference and the output na voltage, let's say, may corresponding concentration yun. And that topic is electrochemistry, especially Nernst equation, okay? Which we will discuss later. So, yun yung isang application ng electrochem in your field. No? By just determining the changes in the voltage or in the electric current of your sample, you can determine the concentration. Okay? So, ganyan siya ka-related sa inyong field. Okay? So, what else? We have the pH meter, which we should all be familiar unless hindi tayo nakapag-lab nung high school, which is true for others. No? Pero anyway, so dapat medyo familiar tayo. So this is a pH meter. This is collected to a electrical supply. And then you have here the wire connecting to the electrode. Paano to ginagamit? Yung electrode, nilulublob nyo sa water. Okay? So nilulublob nyo yun sa suka, sa tubig. Okay? So basta kung saan nyo siya nilulublob na, basta dyan siya sa water. Then what will happen? If you allow the pH meter to read the voltage of the solution, pwede mo malaman yung concentration ng hydrogen in the form of pH. Okay? So ibig sabihin, this is also another application of electrochem. By determining the voltage that this solution can pass through, pwede mo malaman yung concentration ng inyong substances, especially hydronium ion. Okay? So, yun. So, it seems na hindi siya, apparent, no? Kasi pag sinabing electrochem, ang pumapasok usually sa isip natin is batteries. But in reality, electrochemistry is a very huge topic, no? Very wide yung applications niya. So, other than engineering and pure sciences, you can use this topic to create devices which can measure the amounts of particles in our systems, no? Malay nyo, one day, makagawa kayo ng version nito that can be used to test urine. Okay? Kasi currently, ang urinalysis ay spectrophotometric analysis. Didiscuss natin yung next semester. Based sa napanood kong method of urinalysis, you will collect a urine sample, then may paper doon na ilulublob mo doon, and then magkukulay-kulay yon. Tapos yung kulay-kulay ng papel na yon, lalagay mo sa spectrometer to count kung anong concentration ng inyong ions present in that. No? Malay nyo, one day, you will be able to create something like this, no? Na instead na ganun, pwede i-test ng mga tao yung mga urine nila at home, no? Okay? So, other than this, pwede urine, di ba? Malay mo lang, lulublob lang nila yung test strip sa urine, then lalabas na yung creatinine, yung uric acid, no? Kung may hemoglobin ba, mga ganun na. So, yan. Hopefully, one day, one of you will be able to discover that, no? Kasi kayo naman yung gagamit na, no? Okay? But yan, that's the idea. Electrochemistry is a very wide topic. It has many applications, especially in your field, okay? Ibig sabihin, understanding this topic will allow you to understand these devices more, okay? Mas ma-appreciate mo sila when you know this topic. Okay? So again, before natin sila i-appreciate uli, focus ulit tayo on our main topic, okay? So, in electrochemistry, we usually encounter electrochemical cells, no? Okay? So, ito yung mga uri ng electrochemical cells natin, yung mga devices na yan mismo. But in simplification, ganito yung general na itsura niya. And this is the one, itong picture sa kanan, this is my experiment with my students in engineering before, no? Okay. So when we have electrochemical cells, it is a system that consists of electrodes that dip into an electrolyte in which the chemical reaction either uses or generates electric current. So ibig sabihin lang yan, ang electrochemical cell can be described as this, no? You should have electrodes, okay? So yung mga electrodes, yun yung mga nilulublob, okay? So you should have electrodes that are dipped into the solution. So it could be water, or it could be metal ion solution. Okay, and they are connected, using wires. Okay, and then depending on the type of reaction that's happening here, it could either generate or use electricity. Okay, so if we take a look at this picture here sa gilid, so this photo was taken last 2019. So pinagawa ko to sa students ko sa engineering para ma-appreciate namin to and yung application niya in energy production. So pinagawa ko doon, we have two solutions of metal ions. We have magnesium here, we have copper here. Then I have magnesium ribbon here. This serves as the electrode. And I have copper wire here. This serves as the electrode as well. And itong something sa gitna, this is called the salt bridge. Okay. So the purpose of the salt bridge is just to maintain the neutrality of charges. Okay. Siya yung pang neutral lang ng charge. So what happens here is that look at the voltmeter, no. Medyo luma na yung voltmeter. Sa PUP kasi ito eh. So luma na yung mga gamit namin doon. So look at the voltmeter. This is the 0 volts. Asan yung meter? Andun, no? Somewhere in 1.5 volts. So ibig sabihin, itong topic na to, hindi siya joke time kasi as you can see, ito, buhay na buhay yung picture. It tells us that this system can produce electricity. Okay? So ibig sabihin, you can create battery out of this, no? And apparently, yun, may voltage reading siya na positive. Ibig sabihin, pwede mo to gamitin to power up devices. Trinay namin to light LED lights, no? Kaso yung nabili naming LED light is 2 volts ang kailangan, 1.5 to. So hindi gumana. Okay. So siguro if we connect this with other batteries, then yun, doon siya gagana. Okay. But anyway, this is not a failure kasi as you can see, may voltage reading tayo. Ano? So from 0, nandun yung dial sa 1.5 volts. So that means this is real, okay? So totoo that we can create batteries out of chemicals lang in the laboratory, okay? So this is how the electrochemical cell will look like now. If the reaction, if the cell produces electricity, then we call it a galvanic cell or voltaic cell. So again, if the cell produces electricity, it is called galvanic or voltaic cell. Voltaic in honor of Alessandro Volta, no? The one who is in charge of all this electricity stuff, no? Si Alessandro Volta. Anyway, so yan. Pag yan ay nagpo-produce ng kuryente, voltaic. Pag yan naman ay gumagamit ng kuryente, that's electrolytic. Okay? So the thing here sa right is a voltaic cell because it produces electricity. Positive yung kanyang cell potential. Okay? Positive yung voltage niya. But these two on the left are electrolytic cells. No? So when we say electrolytic cells, these are cells in which you have to provide the electricity for the reaction to happen. Okay? So kung galvanic yan, the reaction will happen and it will provide electricity. Ito naman, baliktad. You have to provide electricity para mangyari yung reaction. So those types of cells that needs electricity for the reaction to happen are called electrolytic cells. Okay? So ito yung two examples niyan. On the left, we have this. No? You can actually do this at home provided that you have 9 volts battery. Yung square na battery, yan yung gagamitin nyo dito. Then, kailangan may pencil kayo. Okay. So, on this left reaction, we have here water solution. No? Nilagyan lang ng onting asin yan. Then, I have two inverted test tubes. And then, when I connected the pencil sa battery, yes, it can allow electricity to pass through it, no? Yung carbon, pwede yung mag-transfer ng kuryente. Okay. So, ginawa mo, i-shave mo yung end ng dulo ng pencil, yung other end, pati yung other end. No? I-shave mo yon until ma-expose yung carbon. Then, gamit ka alligator clip, no? Tapos yan, lublub mo yun sa tubig na may asin. What will happen is that, magbabubbles yung water. So, what is happening here, no? So, yung ating water, hindi yan magiging hydrogen gas and oxygen gas unless kuryentehin mo. Yun yung nangyayari dito. Okay? So, yung water natin, nag-evaporate lang yan into gas. Pero, kung gusto mo, mag-split siya into two molecules, hydrogen gas and oxygen gas, then you have to provide electricity doon. Kukuryentehin mo yung tubig. Okay? Literal na kuryente. Okay? So, ganun ginawa namin. So, we connected this to pencil sa battery. Nilublob namin sa solution. And then, the purpose of the the test tube is to collect the gases. Okay? So, on one test tube, hydrogen gas yung na-collect. On the other, oxygen gas yung na-collect. Na. So, we actually allow this to run over, I think, 2 oras ata namin to ginawa, no? Until marami na kaming hydrogen gas na nakolekta, pati oxygen gas. And to prove that, that hindi to joke time, totoo tong reaction na to. Ang ginawa ko sa students ko is, 'di ba, ang dami na naming hydrogen gas na na-collect. So, kinuha ko yung test tube. Nagsindi ako ng lighter. Nung binuksan ko yung container na may hydrogen gas, nagliyab yung hydrogen gas. Okay? So, hindi siya joke time, no? And this can be done at home. But again, you have to be careful because this is combustible. Okay? So, ibig sabihin, totoo yung topic na to. Okay? And then the other one is this one, the electroplating, which I know is very familiar tayo, especially the girls, no? Kapag kayo ay may mga jewelry that are gold-plated or silver-plated, no? So, ayan. Ito yung ginagamit, electroplating. So, ang mangyayari dyan, ito, susi ko to sa dorm. Pag face-to-face kasi nasa dorm ako, no? Layo kasi ng Valenzuela sa Manila. Okay. So, ito yung susi ko sa dorm. Kasi walang nagbibigay ng susi. Di sabi ko, di akin na lang. Ayan. So, I submerge it in copper solution. Kaso, if you just submerge it into copper solution, hindi kakabit yung copper ions sa bakal. Ano gagawin mo? Kuryentehin mo. Okay. So, when you provide electricity dito, what will happen is that mangyayari yung redox reaction. Diba? Remember, reduction reaction is gaining of electrons. So, yung battery natin that will provide electrons for the metal ions to be deposited on the surface of the key, no? On the metal. Okay. So, ganun nangyari. Yung mga copper 2 plus dyan, na-deposit siya sa surface ng bakal. So, nang kinuha ko yung susi ko, may copper na siya. Okay. And ganun ginagawa yung mga copper-coated materials sa bahay. For example, yung mga cookware. Okay. Yung mga cookware natin na copper-coated, no? Mga antibacterial. Totoo yun, no? Antibacterial yung mga copper. Okay. Provided that purong bakal yun. Okay, so ibig sabihin, yung copper mask, hindi yun totoo. Okay. Kasi for copper to be effective in killing germs, you have to have at least 99% copper, which is technically bakal dapat yung copper na nandyan. Kapag kapag copper plated yan, totoo yun. Okay, so ginagamit yun sa India, for example, and even in Africa, no? So, effective daw to disinfect the hospital kapag merong kang copper-coated na materials. No? Sa Africa ata yung napanood kong YouTube video. Okay. So, ganun. Yung copper mask kasi, that is not 99% copper. At saka, may butas yun sa ilalim. So, it is nonsense to use. No? May butas yun sa ilalim. Ba't kasi magagamit nun? So, you just use surgical mask. No? So, don't compromise your health over aesthetics. No? dali lang mag-picture sa Instagram. Pero yung buhay, that's so important, no? Para mawala lang dahil sa copper mask. So yun ha. So marketing ganap lang nila yung copper mask. Okay? And take that from me kasi bilang chemist, may mga friends ako that studied copper, no? And they found na effective talaga siyang antimicrobial, no? Antibacterial. Okay? Yun, antibacterial sila. But on higher concentrations. Pero kapag less than 99% yung copper, nonsense siya. Okay? Wala lang. So yan, share ko lang sa inyo kasi you need to know that bilang medtech. Okay? So yun, ito yung ginagawa sa copper coating. No? For example, sa silver coating, pati sa gold plating, ganito din. Same process lang din. Okay? So, instead na copper to, lalagyan mo ng gold solution. Okay? Gold chloride o kaya silver chloride. Ayan. Magpe-precipitate yan. Silver nitrate pala, sorry. Okay? So, ganun lang. Okay? And these are the terms that you need to know about electrochemical cells, no? Papansin nyo, the electrochemical cells has 3 parts, no? One on the left, one on the middle, and one on the right, no? So the one on the left is called the anode. So this is called the anode. And the one on the right is called the cathode. Okay. So the reaction that happens on the left, the reaction that happens on the left or in the anode is called the oxidation reaction. So dito nangyari oxidation reaction. Again, what's oxidation reaction? Oxidation is losing electrons, di ba? Remember our mnemonic oil rig o kaya Leora Geroa. Ay, mga student ko dati alam yan kasi nadaanan namin yan eh. Hopefully nakwento din sa inyo ng teacher niya. Okay, so this is oxidation reaction. Oxidation is losing electrons. So what happens here is that your metal turns into ions. Okay? So natutunaw yung metal dito on this reaction. And together with it, the electron will be provided. No? Okay. May lalabas na electron dyan, passing through the circuitry and going to the right side, which is the cathode. Okay? So yung electron na nilabas na ito, mapupunta sa kabila, dito sa cathode, wherein dun mangyayari yung reduction reaction. So in this particular example, we have silver. Mangyayari doon, when you provide electrons, the silver will be reduced to silver metal. Okay? So ganito yung ginagawa sa copper coating. So, pwede palitan mo to ng bakal. Okay? Palitan mo to ng susi. Okay? O kaya jewelry. Yan. So silver coating mangyayari dyan. Okay? So yan, so this is how the electrochemical cell will look like, especially voltaic cells. No? So on the left, you have your anode, where the oxidation happens, and on the right, you have the cathode, where the reduction reaction happens. And in between them, we have this thing called the salt bridge. No? This is the salt bridge. Okay. So again, as I told you earlier, the purpose of the salt bridge is to maintain electrical neutrality. So mapapansin mo, this solution contains positive particles. Ganun din dito, positive particles. So to maintain them neutral, you need to add a salt bridge. Saan gawa yan? Yung ginawa ko sa experiment na to, gelatin na may asin. Ayun na yun, gelatin na may asin lang yan. So, alam ko ni-rush ko yung paggawa niyan kasi wala sila mahanap. Kaya ako na gumawa. Okay. So, ganun lang. Gelatin na may asin. And ang gagawin ng asin is that yung ions nila, it will move doon sa charged particles. Yun lang. To maintain the balance. The mnemonic for this one is Oxan Red Cat. Okay, so if you watch my lab video, na-discuss ko to sa kanila yesterday. Oxan red cat, oxidation, anode, reduction, cathode. Ayan. Hindi mo na kailangan kabisaduhin to lahat. No? Okay. So again, the mnemonic for this one is the oxan red cat. Oxidation, anode, reduction, cathode. And yung nasa left ay anode and yung nasa right ay cathode. Ang abbreviation ko naman dito ay ABC. Anode, bridge, cathode. Diba? Daming abbreviation, no? Daming mnemonics ko. Ganun talaga. Para hindi na ma-stress utak mo. Okay. So, yan. So again, these are the mnemonic devices that we can use in Electrochem to quickly memorize yung setups natin. Oxan red cat, oxidation anode, reduction cathode, ABC, meaning anode, bridge, cathode. Anode sa left, bridge sa gitna, cathode sa right. Okay? So, yan. Okay. So, in your laboratory, you were also able to discuss this part, no? Hopefully, na-discuss na. Pero if not, then ito yon. Okay. So, na-discuss na rin to siguro sa lab nyo, no? The standard cell potential. So, when we say standard cell potential, ito yung voltage ng cell mo. This is the voltage of your reaction. Okay. So, to solve for the voltage of the reaction, you get the E cell equals E cathode minus E anode. Okay. Ang siguro tinuro sa inyo sa lab is E left, E right minus E left, di ba? Even if you check your textbook, ganyan yung sabi doon, E right minus E left. Bakit naging ganun? Kasi ano ba yung nasa right? Cathode. Okay? Ano yung nasa left? Anode. Okay? Kaya sabi niya, right minus left. But I don't really like that. To be honest, I hate that that notation kasi nakakalimutan nyo yung ano ba yung right, ano ba yung left, no? So ganun kasi yung problem dun eh. If you don't know which is the cathode, which is the anode, basta naalala mo na lang right, left, wala na. So wala na. Pag tinanong ko kayo ng tricky problems, wala na. Okay? So again, I really don't like this. Although ito yung nasa libro, I prefer this one because this is more consistent with our mnemonics. Okay, so that is cathode minus anode or right minus left according to the textbook. Okay, so for example, you see this thing is called the cell notation. So this thing is called the cell notation. Itong isang buong to. Ano yung binibigay sa ating info ng cell notation? Ito yung ABC. Anode, bridge, cathode. Usually, yung bridge may double line in between. Okay. So, ibig sabihin nun, bridge. So, ito yung cell notation and it is composed of 3 parts. On the left, you have the anode. In the middle, you have the bridge. And on the right, you have your cathode. So, on the left, dito yung nangyayari yung oxidation reaction. So the reaction here is from copper, nagiging copper 2 plus siya. Basically, you just write an arrow from left to right. Copper to copper 2 plus. So this is the oxidation reaction. On the right side, you have the reduction reaction. So that is Ag plus to Ag. Okay? So yan yung oxidation, ito yung reduction. So again, whenever you see a cell notation, it looks like this. Split mo yan into 3 parts. Anode, bridge, cathode. No? So the reaction on the left tells you the oxidation reaction from Cu to Cu2+. On the right side, you have the Ag plus to Ag. Okay? So ito yung oxidation reaction mo, and this one is the reduction reaction. So if you're going to convert this into an equation, balance mo na lang to. I hope marunong na mag-balance. You add 2 electrons plus electron. If your electrons are not equal, then you have to get their least common multiple. Okay. Kailangan kasi pantay yung dami ng electrons. Okay. So the least common multiple of 2 and 1 is 2. Okay. So that means I have to multiply this equation by 2. So I have 2 electrons plus 2 Ag plus producing 2 Ag. So if I combine these 2 equations, I will get lahat ng nasa left side, kopyahin natin. 2 electron, 2 Ag plus, copper, producing right side na. Lahat ng nasa products, copper 2 plus, 2 electron, and 2 Ag. Okay? So I suppose alam niyo na 'to, no? Pero if not, ayan. Panoorin niyo na lang din yung lab vid ko. Yan, mas dahan-dahan ako doon. Sobrang bagal ko, 2 hours kami. Ayan. Anyway, so yan. Ayan, so ito. Pero pag di pa marunong uli mag-balance, just watch my video na in-upload yesterday. Kasi sakit ng lalamunan ko until now naman, no. Kaya puro lecture lang inattendan ko. Kasi bihira na nga tayo magkita, baka magtampo na kayo. Okay. Ayan. So kayo lang mga minute ko today. Yung lab hindi. Okay. Kaya na nila yan. Naturuan ko na sila eh. Okay. So yung electrons, pwede mo yun i-cancel. You have 2 electrons here, 2 electrons there. So you can cancel that. And your final equation will look like this. 2Ag plus Cu producing Cu2 plus and 2Ag. Okay? But take note that 2 electrons ang ginamit natin for the reaction. And that is important later. Don't forget that. Okay? So yan, that's how you interpret cell notation. Okay? So if you want to convert cell notations into equation, just follow what I said. This is copper to copper 2 plus, yun yung oxidation reaction mo. And the reduction reaction is Ag plus 2Ag. Okay? You just balance them and combine them, you will get the equation. Okay? Anyway, so na-discuss na yan sa lab. Skip na natin yan. Let us now solve for the cell potential. Okay? So this was also discussed in lab. Okay? But let's assume na hindi pa natuturo. So paano to? Okay? So gagawin nyo is that you will find the cell potential for the anode and the cathode, no? Remember that your anode is the copper 2 plus, and your cathode is the silver plus. Okay? So gagawin mo, hahanapin mo yung mga chemical species na yon in this table called the standard reduction potential table, SRP table. So hanapin mo dyan yung mga chemicals mo. Okay? It doesn't matter whether baliktad siya or not. Okay? Basta andun yung chemicals mo. Okay. And be careful with their charges. Okay? Okay? Kasi meron dito copper 2 plus to copper plus. Ang gusto natin is copper 2 plus copper lang. Okay? So ganun gagawin nyo once you identified kung ano yung anode, ano yung cathode, look for the species in the table and hanapin yung kanilang corresponding cell potential in volts. Okay? So let's look for copper. Ito medyo ayun, nakita ko agad. Nag-a-assume lang ako, hindi ko alam kasi para sabay-sabay tayo kunwari. Pero kanina pa akong umaga nagsosolve dito kaya alam ko na yung sagot. Okay. So this is copper 2 plus copper system. Ayan. So ito yung reaction na yun. Again, it doesn't matter if baliktad to or not, no? Basta yung species mo ay andon. So kung titignan mo sa right side, this potential, this has a potential of 0.34 volts. Positive 0.34 volts. How about the anode? We have the silver ion, silver. Hanapin uli sa table. Hanapin sa lamesa. Ayun, nakita ko na agad. Ayun, nawala. Ano ba yan? Maduling ako. Ayun, nakita ko na. So for silver plus, no? Ito yan, silver plus silver. Ang kanyang cell potential is 0.80 daw. Okay? So you just copy it here. Also positive. Okay? So to get the cell potential, that is the cathode minus the anode. O kaya, E right minus E left. Okay? So, yan. So, E cathode is 0.80 volts minus E anode, which is 0.34 volts. And the cell potential will be 0.46. Okay. So yun na yun, 0.46. Ibig sabihin, if you connect that to a voltmeter, for example, yung ginawa namin dito last year, If you connect that to a voltmeter, papalo yun sa 0.46. Okay? Exactly 0.46. Okay? So, yan. So, hindi yung magic chemistry yan. Okay? So, by the way, what is a standard potential pala? Ano pala meaning ng standard? No? Titration ba yan? Not really. Okay. So, when we say standards, no? Pag sinabi nating standard sa electrochemistry, ano to? We assume that the concentration is 1 molar and yung pressure ay 1 atm. So standard conditions are conditions wherein the concentration are 1 molar each and then yung pressure ay 1 atm each for each chemicals na nandun. Okay? So ito yung assumption natin parate kapag standard. Otherwise, kapag hindi yan 1 molar, hindi yan 1 atm, we call that non-standard. Okay? And by the way, we denote na standard yan kapag may circle sa taas. No? Pag may bilog siya sa taas, this is pronounced as naught. Okay? So that's E naught cell equals E naught cathode minus E naught anode. No? When you have a naught, that is a standard condition. And yung mga bilog sa taas, naught. Yan. Yan. Ayun lang. Let's proceed. If you have non-standard condition naman, that means hindi ka 1 molar, hindi ka rin 1 atm. If you don't have those conditions, no, then that means non-standard yan. Okay? So the equation to be used when solving for non-standard cell potential is called the Nernst equation. And this is the Nernst equation. E cell equals E naught cell minus 0.0592 over NE log Q. So, hindi ko na to i-derive, no? Kasi mahaba-habang derivation yan. But this is the Nernst equation. Madali lang to i-derive. Imagine nyo na magde-derive ko lang equation, tapos ipapangalan na siya sa inyo. Iba talaga nagagawa ng walang internet dati. Okay? So, this is the Nernst equation. This is used when you have non-standard systems. Pag standard, ganito lang. Boring. Pero kapag non-standard, exciting yung equation. Okay? So, yan. So, let's have this example. Solve for the cell potential of this system. Okay? As you can see, naka-indicate yung concentration ng ating ions. No? Copper 2 plus is 0.02 molar. Yung silver is 0.02 molar lang din. So, paano ko gagamitin to? Ganito. Do I know the E naught cell? Yes. Alam ko na yan. Nasolve ko na kanina eh. Okay. So, yung E naught cell dito is yung nasa table lang din. Okay. So, ito yon 0.46. How about Ne? Ne is the moles of electrons in the balance equation. Ang tanong, ano yung sinabi ko kanina? Ilang moles ng electron meron sa reaction na to? 2, di ba? Yung kinancel ko ng electrons kanina, 2. O yun. Dito mo siya gagamitin. Okay? So, important yon. So, I have 2 moles of electrons here. And the E naught cell, or the standard cell potential, is 0.46 volts positive. What is Q? Q is the reaction quotient. Okay? And you know, reaction quotient is similar with equilibrium constant. No? So, similar siya with equilibrium constant. So, it means, kailangan may correct equation tayo. No? So, kunin natin yung equation para alam natin kung ano ilalagay sa Q. Okay? So, if you convert this cell notation into an equation, which I gave earlier, ganito itsura nyon, copper, 2Ag plus, copper 2 plus, and 2Ag. So, this is the balance equation, which I gave earlier, diba? Ayan. So, yung mga solids, for example, itong silver, itong copper, hindi mo siya isusulat sa Q. Because again, Q is same as the K. Parehas lang siya ng way of writing. Ibig sabihin, yung mga solids, hindi mo siya isusulat doon. Okay? Yung ions, yung mga aqueous, yan, sulat mo yan. What if may gas po dyan? If may gas yan, isama mo na rin. Okay? Kasi remember, ang ating equilibrium, pinaghihiwalay natin yung Kp pati Kc. But for Q, wala siyang pake. Okay? Kung gas yan or aqueous yan, basta isama mo siya doon. Okay? So, ibig sabihin, kapag may hydrogen gas ka dyan, for example, isama mo na rin siya doon. Q naman kasi yan eh, hindi naman yan K. Okay? So, yun lang. Take note of that, no? Yung gases ay isasama na rin natin sa expression. Now, we now know the equation, then we can write the Nernst equation. Okay? Sulat na natin yung Nernst equation natin. So, E naught cell is 0.46 volts minus 0.0592 over mole ng electron is yung mole ng electrons dito sa balance equation, yung kinancel natin. 2 yon. Okay? So, lagay mo 2. Logarithm ng Q. How do you write Q? Numerator ang product, denominator ang reactant. Okay? So, on the numerator, sinususulat? Copper lang. Copper lang. Okay? Yung silver, hindi mo siya susulat because it is solid. You don't write solid or liquids. No? Ang pwede lang isulat ay aqueous and gas. Okay? Yun yung mga ions, pati yung mga gas. So, yan. So, ito, sulat mo yan. Ito, hindi. On the denominator, you have your reactants. Yung copper, di mo isusulat yan kasi solid yan. But for Ag+, yan, susulat mo yan. Ag+. And don't forget, the coefficients are converted to exponents. So, may 2 yan. So, gawin mong square. Okay. What is concentration ng copper 2+? Sabi sa problem 002. Yung Ag ay 0.02 pero naka-square. Okay? So let's plug this in our calculator and then we will get E cell. Okay? Let me plug it sa calculator natin dito para makita nyo kung ano pinipindot ko. Okay. So we have 0.46 minus 0.0592 over 2 electrons logarithm 0.02 then ang nasa baba ay 0.02 square. Don't forget the square. This is now the new cell potential which is 0.41 volts. Ayan. So, ano nangyari? When you change the concentration, the voltage changes. Okay? Ito yung logic ng pH meter, pati ng glucose meter. Pag nagbago yung voltage, nagbago yung concentration. Papansin nyo yan. So, pag nagbago yung voltage mo, malamang nagbago yung concentration. Yun lang naman yung pwede magbago eh. 'Di ba? So, ganun yung ginagawa ng mga pH meter and the glucose meter. So, kumbaga nakaprogram na yung Nernst equation doon. Ang kailangan na lang niya alamin is the voltage that the solution can pass through. Okay? So, depending on the voltage of the solution, dun niya pwede malaman yung concentration. Yun yung ilalagay niya sa display. Kunwari, 120 millimoles per deciliter ka, ang taas ng sugar levels mo. Kaka-milk tea mo yan, di ba? Kaya kunwari, pH meter. Lalabas doon, pH naman. So, yun, nine-negative log na niya agad yung concentration. Okay? So, again, sa equation mo makikita yung relationship ng voltage and the concentration. That's the Nernst equation. Yan na. Makikita mo, by changing the concentrations, you change the voltage. Ganun yung ginagawa ng mga devices natin, such as pH meter. Okay? So, ang galing, no? Ibig sabihin, kung kaya nila, dapat kaya natin i-solve yun. Kasi tayo yung gumawa ng machines, no? We should never be, ano, uh, surpassed by machines, no? Tayo pa rin mga supreme. Ayan. So, anyway. So, yun lang. Hopefully, nakikita nyo na yung pinupunto ko kanina. Na pag nagbago yung voltage, magbabago concentration. Ganito yon. Ito naman, binago ko yung concentration, nagbago voltage. Okay. Pero kapag pH meter yan, yung voltage nagbabago, so inaalam niya yung concentration. Baliktad. Okay. Yan. And this allowed us to measure lots of stuff sa paligid natin. Okay. So, yan. Malaki ang pasalamat natin sa electrochem. No? Because our lives today will not be the same without electrochemistry. No? Imagine mo, nakalampara pa rin siguro tayo ngayon kapag walang electrochem. Anyway, so I'll be giving this one for you to practice. Okay. So the half equations will be this one for the anode and for the cathode. Bigay ko na ha. Kasi ito medyo hindi obvious eh. So this is the half equation. And ito naman sa isa. Okay. So these are the equation in the anode, in the cathode. Combine them so you will know the overall reaction. Okay, so alamin mo yung overall reaction and yun yung gagamitin mo sa Q, sa reaction quotient. Plug in mo na lang yung mga pwede ilagay doon. And what else? Look for the E0 cell. Okay, so again, E0 cell is the E0 cathode minus E0 anode. So ayan, nasa table yan. Dito yan. Just look up na lang sa table. Okay. So I will upload the answers dito sa problem na to in our worksheet by Saturday. Kaso ang dami kong gagawin this Saturday pero unahin ko gawin yun to. Kasi kayo unang magkuquiz eh. Kaya yan. Pag-pray nyo na lang maaga ako magising. Anyway. So yun lang. Binigay ko na yung reaction hanapin nyo na lang dito yan. Solve for E0 cell. Then write the proper equation for Q. Then plug in mo yung concentration. And by the way, yung concentration ng Cl ay 0.02. H plus is 0.02 then. And then yung hydrogen gas is 0.8 atm. So ito sabi dito yung dalawang yan ay 0.02 molar yung concentration nila. Yun lang. Okay, so yun lang. So I'll leave that to you for your practice na. Now, when solving for equilibrium constant, we can't use the Nernst equation. Okay. Actually pwede pero i-derive mo pa Pero instead na mag-derive tayo, let's use this other way na lang, okay? So let's use the free energy method of solving for the equilibrium constant, okay? So what is the free energy, So the free energy is one of the thermodynamic quantities, that tells us about the spontaneity of reaction, okay? So ito yung nagsasabi whether a reaction is spontaneous or not, Okay. And if your delta G is positive, ibig sabihin nun this is non-spontaneous. Ibig sabihin hindi mangyayari yung reaction. If your delta G is negative, then that is spontaneous. Okay. Ibig sabihin the reaction will occur. Okay. So yan lang. So one equation for us to determine this, the free energy change of any electrochemical reaction is this one. So that's delta G equals negative NF E cell, wherein N is the moles of electron. Mole of electron, yun yung binalance natin kanina, yung kinancel mo. So, kanina 2 yon, di ba? And F is called the Faraday's constant. Faraday's. Okay, so that's the Faraday's constant, which has a value of 96485 coulombs per mole ata yan. Yeah, I think. Verify ko yung unit. Baliktad ata ako. Pero yung number is 96485. No? Tama pala yung unit ko. Coulombs per mole. Okay. So, yan. That's the Faraday's constant. That is the constants we use in physics, no, to determine the electrical quantity of matter. Yan. So, Faraday's constant. And then, inert cell or E cell. Alam nyo na yan. So, that is that's the cell potential. Okay. Cell potential. Okay. So, we can use this to get delta G, or the free energy. And again, kapag yung sagot mo ay negative, spontaneous yon. The reaction will happen. Otherwise, if that's positive, non-spontaneous yon. So, hindi mangyayari yung reaction. You have to do something for that reaction to occur. Pag voltaic cell meron ka, or galvanic cell, you have negative delta G. Voltaic. No? Ayusin ko sulat ko. Okay, so if you have negative delta G value, then voltaic cell yon. Ibig sabihin, it will spontaneously produce electricity. But if your delta G is positive, then it is electrolytic. No? Electrolytic. You have to do something for that reaction to happen. And one of the ways to allow that reaction to happen is to provide electricity. Bigyan mo ng kuryente. For example, sa ating batteries sa cellphone, when my phone discharges, that is spontaneous because the cells in the phone battery produces electricity which is used up by my phone, no? Yan yung ginagamit sa phone, no? Pag siya ay spontaneous. So yung battery, magre-release yan ng electrons, so positive yung E-cell niya. So gagana yung cellphone natin, no? But if magcha-charge ka, then you are doing the reverse reaction. You are doing the non-spontaneous reaction. Binabaliktad mo. So instead na maubos yung electrons, no? Imbes na gamitin yung electrons para ma-discharge yung battery, you are providing electrons para ma-charge yung battery. Yun yung reason ba't kailangan natin siya isaksak sa pader. Hindi sa pader pa, sa saksakan. Okay. So, yun yung reason why do we have to power our devices in order to allow the non-spontaneous reaction, which is yung pag-power up ng batteries. Always kasi power down, no? Bumababa yung power. Pero kung gusto mo kabaliktaran, i-charge mo battery mo. Yan, tataas yung battery percentage mo. Okay? So, if you want to solve for the equilibrium constant naman, we can use this equation here. That's delta G equals negative RT ln K. So R is the gas constant in energy form. Okay, so that's 8.314 joule per mole Kelvin. Galing lang din yan sa sa 0.08206 liter atmosphere per mole Kelvin. But this time energy kailangan natin. Your temperature is in Kelvin. And your K is the equilibrium constant. Okay? So, dalawa yung equation ng delta G. Either ito or ito. So, for electrochemical cell, if you want to solve for the K, you can equate the two equations. No? Pwede ito equal yan dito kasi they are both equal to delta G. Okay? So, let me combine those two equations. We have negative NFE cell equals negative RT ln K. Tanggalin mo lang yung negative. Sinulat ko ulit. Tanggalin mo lang yung negative. Yun, you can solve for the K. Ayun, pwede mo na makuha yung K. The problem here is that the K is inside the ln function. Nasa loob siya ng ln function. Ano gagawin ko? Ang alam natin, kapag log K, pag gusto mo kunin yung K, ano gagawin mo? You make this equation the exponent of base 10, di ba? Gawin mo 10 raised to y equals 10 raised to log K. Magka-cancel yung 10 pati yung log, sabi ng algebra. So, makukuha mo yung K, di ba? So, K is equals to 10 raised to y, sabi ni algebra. What if ln yan? Okay. So, kapag ln yan, that is actually a special form of logarithm. Ang tawag dyan ay natural logarithm. So, instead of using base 10, we have to use the Euler's number, yung letter E, no? Which is 2.71 something something. Okay? So, that's the Euler's number. Yan yung logarithm form, pero ang base niya ay E, hindi 10. Okay? So, sa ibig sabihin, sabi ni algebra, no? If you have ln k, kung gusto mo kunin yung k, gagawin mo yung exponent ng e, hindi ng 10. So, e raised to y equals e raised to ln k. According to algebra, e and ln will cancel out. So, e raised to y is equals to k. Yun. Ganun gagawin. So, again, kapag log, ang pang-counter doon ay 10. Pag ln, ang pang-counter doon ay e, the Euler's number, or the exponential function. So if you know your algebra very well, this must be, this must not be new to you. Pero if hindi nyo feel yung algebra nyo nung senior high school, that's okay lang kasi binigay ko na. Okay? But take note of the subtle difference. No? Ang log ay base 10, ang ln ay base e. No? Log base e yan. Okay? So yan. Yan lang. So, ibig sabihin, kung gusto ko palabasin yung K doon, lipat ko muna yung mga constants. Zoom in ko nga dito para mas makita natin. So, yung RT, lipat ko sa kabila, NFE not cell over RT ln K. Kung gusto ko matanggal yung ln, gagawin ko, I will make this equation the exponent of my Euler's number. So, gagawin ko, dito na lang sa left. So that will become E ln K equals E raised to the quantity NF E naught cell over RT. Ano mangyari? Yung E and the ln will cancel out, giving us K equals to this, no? NF E naught cell over RT. This is the equation we use to get the equilibrium constant. Papansin nyo, different siya, no? Different siya sa mga pinag-solve natin noong nakaraan. Yes, different talaga siya. Kasi electrochemistry is another world to eh. More on physics kasi to talaga. But we can apply this in chemical systems. Hopefully, okay tayo sa derivation na. Basta yung binox ko, yun na yung gagamitin natin. But again, if you want to know saan galing yan, hindi ko yung kinuha out of nowhere, yun yung derivation. So let's apply this problem. Ito. Find the equilibrium constant for the reaction below. Ito, yung sinabi ko dito at equilibrium, E cell is equal, are both equal. Ang ginawa ko kasi sa section 2, yung Nernst equation, dito ko dinerive yung K. Nag-derive pa kami. Kaso, naisip ko, pwede rin naman gumamit ng delta G. Kalimutan ko. So, ito kasi nasa libro eh. Ganito yung nasa libro. Yung Nernst equation, pagsasamahin mo to get the equilibrium constant. Pero, naalala ko na lang, ay pwede nga pala delta G. Kaso tapos na klase namin. Kaya, yun. sabihin ko na lang sila. Anyway, same pa rin naman yung answer na makukuha mo. Mas mahaba lang derivation dito. Okay, so ito yung shortcut. Bigay ko na sa inyo yung shortcut. Yung dinerive nating equation dito. Okay. So what do we know about this reaction? This reaction is same as yung mga previous na sinagutan natin, no? So in order to solve for K, that is the exponential NF E naught cell over RT. Okay? Yan yung gagamitin nating equation. What is N? N is the mole of electron, which is 2 moles, okay, of electron. F is the Faraday's constant, which is 96485 coulombs per mole. By the way, yung coulombs per mole, this is also equal to joule per volt mole. Yan, kung gusto mo mag-cancel out ng units. Yan, puro physics na yan. Kung naaalala nyo pa sa physics nyo. The E naught cell, nakuha na natin to kanina. For 0.46 volts yon. Okay. R is the gas constant in energy. So that's 8314 joule per mole Kelvin. Then T, pag hindi sinabi, 25 degrees Celsius yan. Or 298.15 Kelvin. Pag hindi sinabi, automatic 25 yan, ha? So, ganun. Yun lang. Let's plug all these numbers into this. Plug in. K equals E. Yung 2 moles, yung number lang kokopyahin ko doon. Faraday's constant, 96485 joule mole volts. E cell, 0.46 volts. R, 8.314 mole Kelvin. Tapos temperature to 98.15 Kelvin. As you can see, all the units will cancel out. Yung joule, yung mole, yung Kelvin, yung volts. So basically, this is dimensionless. Wala siyang unit. Plug in na lang natin sa calcu. Plug in. So to access E, pag may nakita kayong ln, usually nasa taas nun yung exponential. So shift ln. Yan, lalabas yung E na yan. Okay, so that is 2 times 96485 times 0.46. Tapos sa baba, 8314 298. Ay, mali. 298.15. Okay, so that is the key, no? 3.6 times 10 raised to 15. Sa textbook ay, ang sagot dyan ay 4. Yan. So, ni-round off ng libro sa 1 significant figure. Which is okay lang. Kasi multiple choice to, remember. So, yan. Multiple choice quiz tayo dito. Kaya, yan. Pag nabasa nyo to sa libro, nasa libro kasi itong problem na to. Yung approach doon ay yung ginawa ko sa section 1. Nag-derive pa kami. Tapos, after ko mag-discuss, doon ko naalala na may shortcut nga pala. Diba? Sayang, no? Kasi yung klase namin umaga kaya usually, pa ako, nakatulala pa ako. Basta derive lang ako dyan. Pag nahimasmasan na ako, doon ako nakapag-isip. Ay, oo nga, no? May shortcut pala. Hindi ko naturo yung shortcut. Pero yan, if you're interested with the with the derivation, just watch section 1 video. Sa YouTube na rin yan. So yan, sagot natin. You can round it off to 4 times 10 raised to 15, which is on the textbook. Saan possible yung difference? Pwede magkaroon ng difference kapag yung temperature, minsan may 0.15, minsan wala, no? Pero anyway, subtle lang naman yung difference, no? Ang mahalaga, times 10 raised to 15 yan. Okay. So again, knowing that the k is greater than 1, this is greater than 1 raised to 15 nga. So ilan to? So ilan to? Billion ba to? I think this is million billion. Yeah. So ito ay million billion. So 1 million times 1 billion. So ganun kalaki yung k natin. Which suggests that this reaction is going to the products. So ibig sabihin spontaneous talaga to. Yan. Huwag kayong magugulat kung ganyan yung exponent ng K natin. Kasi ganun talaga pag electrochem. So I will leave this to you to work on. Just follow the same process na sinabi ko. And I will give you the cell potential. Alamin mo na lang yung E cell, E not cell. And then, yan. From the E not cell, you can get the K. So, bigay ko yung E cell kasi wala siya sa table. So, let me rewrite that. Ito yung nasa SRP table, yung tinitignan natin na reference. Paki-note na lang ha, screenshot nyo or panoorin nyo na lang uli after the class. To ito. Naantok lang yung 2 ko. 2. Okay, so yan. So those are the cell potential. Alamin mo lang sino yung anode, sino yung cathode. Pag subtractin mo sila, you will get the E naught cell. Plug that into our delta G and you will solve for K. Okay? So basically, kung ano yung ginawa natin earlier, ganun lang din gagawin nyo. Alamin mo moles ng electron. Yan. So I will leave that to you as your activity. Upload ko yung answer sa Canvas by weekends. Yun lang. Okay? Wait lang. Ayan. May baby cat kasi dito. Kinakagat niya yung wire. Anyway, so let's proceed with the second part. Wala pa kalahati pa lang tayo. Okay. So for the second part, we have the redox titration. Okay. Ito mabilisan lang to ha. Okay. So again, yung acid base may titration doon, ang redox meron din, okay? So redox titration is a titration that is involved ang electrochem. Remember kapag acid base tayo, this is how the graph will look like. So you have the pH there, and then you have the volume of titrant here, and ganyan yung itsura ng curve. Pwedeng baliktad or maraming steps depending on the number of equivalence point. Okay? So ito yung itsura ng acid-base titration curve. For electrochemistry, especially for redox titration, ganun pa rin yung itsura. But ang y-axis natin, hindi na siya pH. The y-axis is now the cell potential. And you have the volume of titrant below. And isa lang yung endpoint dito, usually. Isang endpoint lang. Okay? Pwedeng ganyan, pwedeng baliktad. Tapos isang endpoint lang. Okay? So, yan. So, ibig sabihin, we can also do titrations in redox systems. No? And yun, to solve for the E cell, di ba, sa acid-base titration, may ginawa ko, may table doon, ando na yung equations to solve for pH. Ganon din dito. Okay? So, for redox titration, there are equations for each stages. No? Okay, so, let me explain bakit sa initial wala. Kasi ang sagot doon, walang redox reaction. Kaya, no equation tayo doon. You will never determine the cell potential initially unless you start adding titrant na. Okay? So wala kasing redox reaction doon. Kaya walang equation for that. Kahit anong textbook, tignan mo, wala talaga yan. Okay? Then, sabi ko nga sa inyo, the time you add your titrant, dun lang mag-start yung redox reaction. So, yan. So, we only have 3 stages for the redox titration. You have the pre-equivalence, equivalence, and the post-equivalence. So, depending on the composition of your solution, there is a corresponding equation. At pre-equivalence point, mostly analyte yung nasa container mo. So, the cell potential can be calculated as the cell potential of the analyte. Okay? So, E na analyte yan. Okay? So, ayan. So, this is the Nernst equation for the analyte. Note natin. Nernst for analyte. Okay. And then Q, take note, this is the reaction quotient, and I gave the equations already na. Binigay ko na yung equation mismo. So plug in mo na lang molarity analyte, volume analyte, molarity titrant, volume titrant. So that's given anyway. Nasa ano naman yan? Nasa problem na mismo. Okay. At post equivalence, mostly titrant yan. So the equation that we will use to get the cell potential is the Nernst equation. The Nernst equation for the titrant. Okay. So you will need to use the Nernst equation for the titrant. Yan lang. And at equivalence, ito yung equation. Medyo kakaiba. So we have 2E system equals E analyte plus E titrant. And you have to consider the coefficients A and B. Okay. So yung derivation nito nasa next slide, although di na natin siya i-focus. Okay. Onti lang bibigay kong ganito. So bakit 2E system? Kasi nga, meron ka ng analyte, meron ka pang titrant. Okay. So basically, you add this and that. So 2E system yon. Dalawa na eh. Meron ka na neto plus ito. Yan. Dalawa na sila. Kaya ganun. Okay. So yan to yung equation na gagamitin mo. But again, I will not focus on this any longer kasi simple lang na titration gagawin natin. So ito yung dahilan bakit ganun yung ating equation dyan. So I gave an example mismo dito. So this is the Nernst equation for the analyte. This is the Nernst equation for the titrant. Okay. So you just combine them. Since sabi natin itong dalawang cell potential na yung nagko-contribute sa solution at equivalence. So this plus that is 2E system plus this. And knowing that ang ating solution ay equivalent na, so lahat to magka-cancel out. So the logarithm of 1 is 0, so your equation can be simplified as this. And yan. So generalization, 2E system equals E cathode plus E anode. Okay. But you have to include the coefficients now. Okay. For in this case, sa mga examples na ibibigay ko later, 1:1 yung ratio nila. Kasi if ano yan, 1 to 2, 1 to 3, 2 to 3, 2 to 5, no? Iba na yung equation na gagamitin mo doon, which is so difficult na. And hindi naman kayo BS Chem, so di na natin gagawin yun. Yung 1-to-1 lang yung pwede natin gawin. Okay? So, kunwari, guide ko lang kayo how to answer this, pero hindi ko siya sasagutan today. Nandiyan na kasi yung answer sa PowerPoint. So, gag-guide ko lang kayo how to start answering this, no? Upload ko to sa worksheet, no? Kasi we have a very limited time. Malapit na pala mag-time. Okay. So, paano to? So, kung paano kayo mag-acid-base titration, ganun lang din dito. Okay? Same process lang din. Okay? So, alamin mo sino analyte, sino titrant. Okay? Rule of thumb is kung sino yung unang sinabi, siya yung analyte. And kung sino yung last na sinabi, siya yung titrant. Okay? So, ibig sabihin, this is your E analyte and this is your E titrant. Okay? So, ganun lang. Una mo pang gagawin, after identifying sino analyte, sino titrant, you will find for the volume of titrant at equivalence point. Okay? So kasi yung volumes na to, iba-ibang stages yon. So for you to know the correct equation for each stages, kailangan alam mo yung equivalence point. No? So like acid-base titration, we know at equivalence point, that is mole analyte equals mole titrant. No? 1-to-1 lang yung gagawin natin. Kaya ito lang. And you know that moles can be expressed as molarity, volume, no? MTVT. We are solving for the volume of titrant at equivalence point, si VTEP, our very close friend. And that's equal to 50 ml. Bakit siya naging 50 ml? Kasi 50 times 0.1 divided by 0.1. So 50 ml yun. So ibig sabihin, this is our equivalence point. These are the pre-equivalence point volumes. And these are the post-equivalence point volumes. So for this part, we use the Nernst for analyte. Okay, yung EA nakuha ko na naman, 'di ba? Yan na yun eh. So yun yung ipa-plug in mo dito. Ito na yung EA. Tapos yung Q, that's molarity analyte, volume analyte minus molarity titrant, volume titrant over molarity titrant, volume titrant. Pa-plug in mo na lang lahat ng numbers. Again, yung EA is yung sa ano lang. Ito lang. Ito lang. Hindi mo ipag-add yung dalawa. Ito lang. Then for the titrant sa post-equivalence, ito lang din. Okay? Hindi ko na muna gagawin yan for now. I-upload ko na lang sa worksheet yung solution. But yan, you can plug in those values. Alam mo naman yung MA, VA, MTVT. Ayan, ito yung makukuha mong sagot. Or at least somewhere near there. Kasi nung pinipindot ko yan sa CalQ, ni-round off ko yan. Kaya ganyan. So yan, as you can see, it looks like acid-base titration then. Again, yung solution, upload ko na lang sa worksheet by the weekend. And yan, kung masagutan nyo yun ng tama, then maybe you can also try doing this. Same problem, different ano nga lang, different given. Okay? So yan. So iba rin yung volume of titrant at equivalence point dito. So yan. Bigay ko na lang muna sa inyo as a practice. But again, I will upload the answers by tomorrow. Okay? Siguro mga hapon yon. Kasi I'm expecting magbabawi ako ng tulog tonight. Okay, going back to our topic, wala na tayong calculation. Salamat sa Diyos. Wala na tayong calculation at this point beyond. Okay. So similar with acid-base titration, redox titration also requires indicators. No? Sometimes they require indicators, sometimes they do not. No? So these are the following types of redox titration. Umiiyak yung baby cat. Wait lang, baba ko lang siya. Ayan. So anyway, so these are the some of the types of titration. So we have the iodimetry, iodometry, permanganate, dichromate. And for each titration, there is a corresponding titrant na. You may ask now, what is iodimetry and what is iodometry? Ano yung difference nila? Bukod sa isang letter lang. So pag sinabi nating iodimetry, this is way to quantify reducing agents, no? And yung iodometry naman, this is used to quantify oxidizing agents. Baliktad sila. So iodometry, oxidizing agents yung mini-measure niya. Iodimetry, reducing agents ang mini-measure niya. Okay? So for both of them, we use the starch indicator. Okay? So starch indicator ginagamit. The transition is blue to colorless or colorless to blue. Okay? So ito medyo ibang kulay siya, no? Kasi pag phenolphthalein, kulay pink, 'di ba? 'Yun yung endpoint natin. Dito naman kulay blue, no? So colorful na. Yan. Pag permanganate naman, this is KMnO4. This is we don't use any indicator here because permanganate is a colored solution. So ibig sabihin kukulay talaga yung solution mo. So, hindi na kami gumagamit ng indicator dyan. What else? Sa permanganate method, this should be done in darkness. Ginagawa to sa kadiliman. Literal na dilim. Bakit? Kasi yung permanganate, this is very sensitive sa light. Okay? So this is very sensitive sa light. So that's why kapag ginagawa to sa lab, kailangan sobrang dilim. Nung ginawa namin to sa lab, ito yung kwento ko last time sa inyo sa types of titration. Nung ginawa namin to sa lab, nung college ako, 2015, third year college na ako noon. 2015, 2016. Ginawa namin, tinapalan namin yung bintana ng tela talaga para super dark ng room. So kami, mga naka-cellphone lights lang kami. Okay. To monitor the color change. Ganun lang. Hindi ko lang makalimutan yung day na to kasi sobrang dilim. Okay. Tapos ang init-init pa. Ayun. Kaya, yun. And then we have the dichromate. So the titrant used is potassium dichromate. The indicator to be used is diphenylamine, and the transition color is the same as permanganate. Okay, so these are just some of the many types of redox titration. Pero okay na yung ito yung alam niya. Okay, again, learn the difference between the two, iodimetry and iodometry. Okay, so lalabas yan sa quiz. Ito yung something unique with ito yung something unique with redox titration. Kasi 'di ba pag acid-base titration, makagawa ka lang ng solution, pwede ka na, diretso ka na mag-titrate, no? But for redox titration, hindi pwedeng dire-direkta. Why? Kasi ganito, if your analyte solution is exposed in the air, pag in-expose mo yan sa air, pwede mag-redox yun. No? And that is the reason why kinakalawang din yung bakal natin. Okay? So the oxygen in the air and the oxygen in the water provides a good environment, no, for the redox reaction to happen. Yun yung reason ba't kinakalawang yung bakal natin sa bahay. Okay? So sa titration ng redox, as much as possible, you don't want the air to interfere with your titration. So instead na tanggalin mo yung hangin, hindi pwede yun. Mamatay tayo. So, ang gagawin mo, you use auxiliary agents. No? So auxiliary agents are chemicals we add in the solution before we start the titration to prevent the oxidation or reduction in the air. So ito yung ating reducing agents. We have the Jones reductor or the Walden reductor. These are the oxidizing agents, sodium bismuthate, ammonium peroxidized sulfate, and hydrogen peroxide. So yan. So before you start titrating, you add these auxiliary agents. No? Yan. So ihalo mo muna siya bago ka mag-start. Also, similar with acid-base titration, okay, may standard solution din tayo dito. Remember, kapag acid-base titration, ang preferred acid ay HCl, ang preferred base ay NaO, sodium hydroxide. Ganon din dito. Okay? Meron din silang preferred na solutions. If your titrant is reducing agent, you can use iron 2 or sodium thiosulfate. Okay? So ito yung ginagamit natin. So iron 2, pwede ito ay iron 2 chloride. Sodium thiosulfate, powder lang yan. No? Yan ay yung gagawin mong titrant. Then kung gusto mo naman oxidizing agent ang inyong titrant, you can use potassium permanganate. Ito yung kulay purple. Okay? Ibig sabihin siya ay isang BTS. And ito yung cerium. Cerium 4, I'm not really familiar with this one kasi expensive daw to. So ito yung purple. Ito yung ginagamit talaga namin. Okay. So these are the preferred. Again, depende pa sa method. No? Kasi there are methods na specific yung ions na gusto niya for the titrant. Pero ito yung common. Okay? Ayan, medyo malapit na tayo matapos. Nagsusugat na yung lalamunan ko rin eh. Okay. Anyway, so we are almost done. So, puro concept na lang to. No? Kaya chika-chika na lang tayo. So, let's talk about potentiometry. So, potentiometry is what we described earlier, no? Yung electrochemical cell. Potentiometry na yon. See, we are determining the potential difference, no? The voltage. Okay. But in potentiometry, instead of calling this the anode and the cathode, we call this the reference and the indicating electrodes. Yun lang yung difference, no? Same lang siya sa kanina. Ang pinagkaiba lang is yung tawag, no? So we have the reference electrode and we have the indicating electrode, okay? The reference electrode is the electrode which is held constant. Ito yung basis for the measurement. And the indicating electrode is the one being determined, no? Ganito yung ginagamit sa pH meter. Okay? So if you check closely the pH meter, inside the glass tube, may tube pa doon na may liquid sa loob. Yun yung reference electrode. Then, yung indicating electrode, yun yung outer tube, no? Na may glass sa ilalim. Yun yung indicating electrode. Okay? So, ito yung ginagamit sa pH meter, the potentiometry. No? And yun, it follows the Nernst equation, just as I said earlier. So, ganito itsura ng mga pH meter dati, pero they were able to combine this into one. Okay? Pinagsama na nila yan into one. Okay. So, what are electrodes? Electrodes are, ito yung mga ginagamit to measure the voltages. No? So, kumbaga, ito yung mga nakalublob sa solution which allows the electrons to be transferred into it or papunta sa labas. Okay? So, dalawang uri ng electrodes in potentiometry. We have the reference and we have the indicator. Again, take note that the reference is fixed. No? Fixed yung kanyang value. And the indicator, ito yung variable. So, ang gagawin ng potentiometry, for example, pH meter, i-compare niya itong indicator sa reference. Yun yung sinasabi ko sa pH meter kanina. Kapag nilublob mo yung electrode, aalamin niya yung difference ng kuryente sa labas, pati ng kuryente sa loob ng reference. So by obtaining the difference, you can get the pH using Nernst equation. Okay? But pH meter is just one of the many examples. No? So these are some of the common reference electrodes used in chemistry, in analytical chem. Yung standard hydrogen electrode, so ito yung precursor ng pH meter natin kasi may hydrogen. So ganito itsura niyang electrode na yan. So you have this gas inlet, gas talaga yan, okay? Hydrogen gas. Then you have your acid solution here and then you have your metal plate which is platinum. So the platinum will act as catalyst for the reaction. No? It provides surface area for the gas to react with the solution. Okay. So yan yung precursor ng pH meter. Pero ayun nga, technology improved. So instead na pag nagpi-pH meter nakakonekta tayo sa tangke, hindi na. Nandun na siya sa isang glass. Kaya nga bawal basagin 'yon. Masyadong mahal 'yon kasi that is a very very technical na object yon. Ang daming nakalagay sa loob nun. May standard hydrogen electrode yon and at the same time, may reference electrode din. Okay? So, that's the primary standard electrode, the standard hydrogen electrode or abbreviated din yan as SHE. No, SHE, standard hydrogen electrode. Other types of electrodes are this, no? The silver-silver chloride electrode. This is used in argentometry titration. Okay. Pag sinabing argentometric, basically may silver. Kaya nga may silver eh. And then we have the saturated calomel electrode. When you say calomel, ito yung lumang term for mercury. So literal na may mercury yung electrode mo dun. Okay. So ito hindi ko na na-encounter to sa lab kasi wala kami neto. Kasi mercury yan, delikado yan. So ito lang yung mga pwede. Hydrogen electrode. Indicator electrodes, so ito yung mga nagbe-measure ng cell potential ng other ions. Ito yung pinagko-compare sa reference. No? So there are three kinds of indicator electrodes. So we have the metal indicator, membrane electrodes, and the ion selective electrodes. So daanan lang natin siya. Metal indicator, ibig sabihin yan, metal yan. Okay? So tatlong uri yan. Either the metal is pure metal, okay? For example, silver metal, copper metal, gold metal, ayun. Yun yung ilulublob mo mismo sa solution mo. Tawag doon ay first kind electrodes. Kung ano yung minimeasure mong ions, yun yung metal na ilalagay mo rin doon. Kunwari, you're determining copper. The copper metal lalagay mo doon. Yun yung mga first kind electrodes. The second kind electrodes naman is ganito. Parang ice cream to, no? Yung ice cream na pure lang is the first kind. Yung second kind, yun yung may pinipig. No? And yung pinipig na yun, that is the precipitates. No? So you have metals here coated with precipitate, for example, AgCl. Ayan. I-coat mo lang siya with that precipitate. Okay. And then you have the third kind electrode. So in third kind electrode, we use metal that is not reactive. Okay. So basically, yung gagawin niya lang is to pass through electrons. Commonly, the metal used here is platinum. Okay, platinum is a very expensive metal, kaya mahal ang mga pH meter kasi meron sila niyan. Alam ko 5K yung electrodes pa lang. Hindi pa kasama yung hindi pa kasama yung ibang setup. Ganun kamahal pH meter. But ko alam, may nakabasag sa amin nun eh. Okay. Next one, the membrane electrodes. Membrane electrodes, these are used to determine the P values. Ayan. We have the pH, PCA, PNO3. Okay. So, ano itsura ng membrane electrodes? Yun yung nasa pH meter. Di ba sa ilalim nun may bilog na glass? Tapos nakakonekta yun. Ano sabi ng teacher nyo? Huwag nyo hawakan yung bilog na glass na yun sa ilalim. Bakit? Magagalit siya. Okay. Kasi, membrane electrode yun. That is very sensitive, no? So, pag nahawakan mo yun, baka masira. Even a small touch can actually break that membrane, no? Okay? So, yung glass na yun sa ilalim ng pH meter, yung bulb na yun, ayan, yun yung membrane electrode, no? So, sa surface nun, dun niya minimeasure yung hydronium concentration. Kaya, sabi sa atin, wag hawakan yun ng kamay. Okay lang ng tissue, pero wag kamay. And actually, yung tissue nga na ginagamit doon, di yung normal na tissue. We use Kim wipes, no? Yung very expensive tissue. Okay, so yan yung ginagamit pang linis niyan. So yan, that is used to determine the pH, PCA, and the PNO3. Obviously, pag pH, ito yung sa acidity ng solution, acidity or basicity. Pag PCA naman, ito yung ginagamit for water analysis, no? For example, if you work in Maynilad or Manila Water, pag ikisa kang chemist doon, pwede gamitin mo PCA meter instead of pH meter. Ang gagawin mo yung water, lulublob mo yung PCA meter doon, and it will determine the amount of calcium in the solution. The higher the calcium, the harder the water is. No? Kaya nga tawag doon hard water. Kasi maraming minerals, especially calcium. Ano yung problem with calcium? Ganito. Diba, kunwari, nasa probinsya kayo, kumuha kayo ng tubig from the well, balon. Pag pinakuluan nyo yon, may puti-puting namumuo dun, diba? Yung puti na yon, that is the mineral, that is the calcium. Okay? Ibig sabihin, the harder the water is, the more calcium there are. Pangit yon sa pipeline natin. So remember, if yung pipeline natin, mag-build up yung calcium dun, mabablock yon. So imagine mo, sasabog yon. Fountain yon, no? Magiging fountain of tubig yon, no? So sayang ang pera ng Maynilad kung ganun, no? So that's why they try to minimize the water hardness. Kaya nga may soft water na tinatawag. So yun, mababa yung kanilang minerals para hindi mag-clog yung mga tubo sa ilalim ng lupa. Kasi if that happened, mawawalan kayo ng tubig sa area nyo, tapos ang hassle pa. Okay? Kasi babaha. No? PNO3, this is used by agriculturists, especially by some farmers, no? Yung mga farmers na medyo advanced in technology. Okay. So, saan to ginagamit? To determine the nitrate concentration in the sand, no? In the soil pala. Okay. So, the higher the nitrate concentration is, the better. Yun nga yung reason ba't sila nagpa-fertilizer to add ammonia and nitrate sa solution. Kaya ammonium nitrate ginagamit doon, no? Para madagdagan yung mga nitrogen compounds. Bakit nitrogen compounds? Kasi remember in your elementary days, no? Sa elementary, tinuturo yung nitrogen fixation, di ba? LM ba yun o high school? Basta alam ko, LM pa lang, nakababasa ko na yun eh. So yun, nitrogen fixation helps the plants to grow, especially the legumes, no? Yung mga may buto-buto. Yan. So yan, so the higher the nitrogen content, the more fertile the land. So yun yung ginagamit nila to measure the fertility of land then. Although again, there are other methods to determine that. Depende sa analyst. Ion selective electrodes, ito yung ions other than this. No? Okay. Kunwari, you want to determine the lead concentration. You want to determine the mercury. No? So yan, yun yung gagamitin mo, ion selective electrodes. Okay. And for the last part, we have the voltammetry. Okay? So voltammetry naman, this is different with potentiometry. Kasi sa potentiometry, voltage yung mini-measure, kaya nga potential. Dito naman sa voltammetry, you are determining the current by changing the voltage. No? So binabago mo yung dalawang parameters. Babaguhin mo yung voltage para malaman mo yung current. No? And in physics, they are both related naman, no? So the reaction is predictable. So ito yung sabi sa physics, VIR, voltage is the product of current times the resistance in ohms, no? 'Di ba? Biglang nagfi-physics tayo dito. Ganun talaga. Okay. So by changing the current with voltage, no, you can produce a graph that's called a voltammogram. And yung itsura ng voltammogram is very different, no? Pakita ko sa inyo isang example ng voltammogram. 'Di ba sa 'di ba sa potentiometry ganito yung itsura, no? You have the E cell, then you have the volume titrant. Sa acid base, you have the pH, then you have the volume titrant. Sa voltammetry iba itsura. Kaya dadaanan lang natin 'to. Tignan mo, ang cute-cute ng graph. Ayan na. Ang tawag nila dyan is duck. Duck shape. Ayan na. Lagyan mo mata, lagyan mo paa. Duck na siya. Ayan. So by changing the potential and the current, you can get this graph which is called the voltammogram. Ayan. So medyo advanced na to, no? Ginagamit na to sa master's degree. Ayan. So ito pa yung ibang itsura ng graph. And ito pa yung ibang itsura. Ayan. So iba-iba yung kanilang itsura. Ayan. Ayun lang, ma-share ko lang. So iba-iba yung itsura ng graph dito sa voltammogram. Okay. So in voltammetry, 'di ba kanina sa potentiometry, dalawang electrodes kailangan. You have the reference and you have the indicating. Sa voltammetry, tatlo. Tatlo yung nakatusok sa solution mo. You have the working electrode, the reference electrode, and the auxiliary electrode. Okay? So yung reference electrode, ganun pa rin yung purpose niya, no? To serve as the baseline, siya yung pagbabasihan ng voltage, no? Or the ampere, no? Okay, so yung working electrode, dito nangyayari yung pagbabago ng ampere ng solution, ay yung current ng solution by changing the voltage, no? So in order to change those parameters, we use small mercury drop or platinum disc, no? Ito literal na mercury magda-drop dyan. So pag graph yan, ganito itsura niyan. Gumaganon-ganon yan. Yun yung nakita nyo kanina sa isang picture, kung nakita nyo siya. Okay, so yun yung ginagamit sa working electrode. So ito yung pinag-change ng ng current pati ng voltage. Reference, ito nga reference siya. So fix yung kanyang potential. Okay, so the common here is the calomel and the EGAGCL. Hindi ginagamit yung SHE dito. And for auxiliary electrode, ito yung taga-measure ng current na. Ito yung taga-bring or taga-receive ng current. Andun lang siya. Standby lang siya sa mga nangyayari. And these are the types of voltammetry. Marami yan. But again, we will not go into more details because okay na tayo sa potentiometry. So just focus on potentiometry and yung sa voltammetry siguro alamin nyo na lang kung ano yung ginagawa sa voltammetry, what are the electrodes. So ito yung itsura ng voltammogram, voltammetry. For example, this is polarimetry or polarography. And so as you can see, there are 3 electrodes attached to it. Okay. So this is the working, the reference, and the auxiliary. So all of them will work to change the current and the potential. So as the current and the potential changes, may graph tayong mabubuo na minsan pa ganon, minsan pa dot, Ayan. And etc. Okay? So yun lang. So basically, tapos na tayo sa chapter 6. Sakit na rin ang lalamunan ko. Anyway, so that will be all. What I wanted to focus for the upcoming quiz ay ito. Isang quiz lang tayo dito. So, thank you, Lord. Isang quiz lang. So, quiz number 6 natin. Isang quiz lang. Maybe I can give multiple attempts. Siguro 2 attempts na. This is composed of 2 problems. 2 parts, So, the first part will be the concepts. And the second part will be the calculation. A majority will be the concepts. Puro concept tayo. Especially mga terms, kasi ang daming terms na binato ko, di ba? So, yun. So, focus on them. And yung calculation, ito yung minority. So, I can't give exact numbers because di ko pa tapos yung quiz dito. Okay. So, I won't give exact numbers. Pwede ito, 11, ito 9. At least majority pa rin yung isa. O pwede naman ito 15, ito 5. 5 items. Ayan. So for the calculation part, focus on the E cell or the E naught cell, delta G and the K, and yung NERNs Yan. Which is the E cell And then yung redox titration. Okay. So yan, again, I will give worksheet for this part, Always sa calculation part ako nagbibigay ng worksheet naman para yung kasi yung solving Kaya yun yung mas mahirap, Ayun lang. So I will upload this maybe by tomorrow, but hindi siya exactly morning. Kasi gagawin ko pa siya, hindi ko pa siya tapos Together with the worksheet, Update ko na lang kaya dito. And what else, about our class, Since aware kayo na may battery exam kayo in the future, which is next year pa naman kayo, So, since hindi nyo na ako magiging teacher nun, makikita nyo na lang ako sa YouTube, So, you can actually watch my recordings there, Pero gagawa ako, by June, July, ang project ko is to make shorter videos, about Gen Chem, Anachem, So, gagawa ko ng short videos about those 2 subjects. And you can use that as a review, for your upcoming battery exam next year. Ayan, yun yung gagawin ko. Okay. May mga student din kasi ako before na magta-take na ng battery exam. So, to extend my help to them, yan, gagawa ko ng shorter video clips. Siguro 5 to 10 minutes na lesson. Tapos putol-putol. Okay? So, I hope na by the time na mag-battery exam kayo, maalala nyo yung YouTube channel natin. So, I will be uploading those review materials there. Okay? And I hope na makatulong yon sa pagpasa nyo sa battery exam in the future. But for now, lecture videos lang tayo sa YouTube. Okay? So, yun lang. Ayan, wala na akong ibang announcement. Okay? So, that will be all for our session today. Na? So, do you have any questions or concerns, clarification? Or if we're good to go, then maybe we can end the session na. So, I think wala naman. Okay. So anyway, so yun lang. I'll see you again next time. No? And again, next week will be our last synchronous session. Okay, last synchronous session na yun. Kita-kita na lang sa face-to-face or sa YouTube. Na? So, and I'll see you again next time. Bye-bye and stay safe, guys.
Thank you po, sir.
Thank you rin po.
Thank you
Bye-bye.
po, sir.